Welcome to Lesson 1.3, Algebraic Expressions. I'm looking on page 16 and 17 in our textbook if you would like to follow along. And the focus of this lesson is to learn to use different variables to represent a set of numbers, particularly in an algebraic expression. So I've posed just a couple of questions to get us started, just to make sure we understand what that means. So my first question is, what is a variable? And simply, a variable is a letter, it's usually written in italics, that represents a number or a quantity in an expression or in an equation. So some common variables you might see might be an x, or a y, or an n. And particularly in this lesson, we're going to learn how to evaluate an expression when we have the value for our variable. So if we know the value or the number that our variable represents. We're going to get into that in a couple of slides though. My second question, what is an expression or an algebraic expression? And simply it's a mathematical expression that contains a variable. Okay, so an example could be 6x minus 4. And this would represent an algebraic expression because I have my variable in this. And an expression just represents a phrase or represents something. So this expression here would represent 6 times a number because we don't know what value that is. So 6 times a number, subtract 4. That's what this expression would represent. So I've posted up a few more examples of algebraic expressions. So on the left side of the screen, you will see the algebraic expressions. And then on the right side of the screen, I've kind of jumbled them all up. And I want you to see if you can match the meaning for those algebraic expressions with the actual expression on the left-hand side. So I just want you to take a moment. So let's look at n plus 3 as an expression. What would that mean in words? Would that mean 7 times a number divided by 20, 3 more than a number, or 8 less than a number? Okay, 7n. Again, which one of these 4 would that represent? Would that algebraic expression represent? N minus 8. So we have our variable, which is n, subtract 8. And then our last one, n, which is our variable, n divided by 20. So take a minute and see if you can match those up with the meanings on the right-hand side. So our n plus 3 represents 3 more than a number, right? We have our number, which is our variable, adding 3, which means 3 more, so 3 more than a number. 7n represents 7 times a number. Remember, when you see a number and a letter, or it could be 2 numbers beside each other, for example, 7 and 2, 2 in brackets, when they're right beside each other and there's no operation in between, it represents multiplication. So 7n means 7 times a number. N subtract 8 would mean 8 less than a number. And then n divided by 20 is a number divided by 20. Right? So these are all vague when it says a number because we don't know what number our variable represents. So the last thing that we're going to look at for this lesson is how to evaluate an algebraic expression. And all that means is when we replace our variable with a number, we're evaluating our expression. So in these sorts of questions, you will have your expression and then you'll have a value or a number for your variable. So I've put one example up here where it asks to evaluate the expression 5k added to 2, where we know that k equals 3. So the value of our variable is 3. And as I'm solving this, I want you to pay attention and follow the steps in how I'm solving it and how I'm showing my work, just so that your work is organized and it's very clear that you're showing all of your steps in your work. So how I'm going to start is I'm going to write out my expression. So 5k added to 2. My second step would just be to replace my variable with my number. So 5 multiplied by 3 added to 2. And I put my 3 in brackets because if I didn't put brackets, it would look like the number 53. And it just keeps it more organized than adding a multiplication sign in there. Because like I said in the previous slide, when you see those two numbers together and there's not an operation in between, we know that represents multiplication. So my next step, keep BEDMAS in mind, would be to go 5 multiplied by 3. So we know that's 15 plus 2. And just, again, keep in mind, I'm doing things one step at a time. I'm showing every step that I'm taking. And then my last step would be to add 15 plus 2, which I know is 17. So we evaluated 5k plus 2, where k equals 3, and we got 17. So let's do one more example where we evaluate an algebraic expression. So my second example, it asks us to evaluate 32 subtract x divided by 4, where we know that x equals 20. So my first step, I'm going to rewrite out the equation. 32 subtract x divided by 4, and I'm just going to rewrite it a little differently just because that's easier for me to look at. So my second step is to take the value of my variable and just to put it into the equation. So 32 subtract 20 over 4, right? So I just put the value of my variable in replace of the x. And now we solve. So keeping BEDMAS in mind again, my first step would be to go 20 divided by 4, which I know is 5. And again, I'm writing my work one step at a time. And then my last step would be 32 subtract 5, which is 27. So those were two examples of how you evaluate an algebraic expression. So just to end off, I just want to give you one practice question that you can do on your own just so you can help solidify and put to use what you've been watching and what you've learned in this lesson. So my question will be for you to evaluate the following algebraic expression. 4n subtract 7, where n equals 3. So there's your question, and come to class with any questions or comments or concerns you might have about this lesson. Thanks for watching.